Heating effect of electric current. Take a piece of nichrome wire, and tie it between the nails. Now, switch on the current. After a minute, switch off the current, and touch the wire. The wire gets hot when an electric current passes through it. This is the heating effect of the electric current. This kind of heating is called ohmic heating or Joule heating. Electric toasters, electric hair dryers, electric irons, electric heaters, and electric ovens are some appliances that get hot when electric. The amount of heat produced in a wire depends on its materials, length, and thickness. Electric fuse. To prevent electric appliances from getting damaged as a result of excessive passage of current through them, we use a safety device called fuse. It consists of a thin wire, usually placed inside a glass or a ceramic cartridge. An alloy of tin and lead is used as safety fuse. It has a low melting point. Fuse is designed such that only a certain maximum amount of current can flow through it. When an electrical short circuit occurs, huge current flows through the circuit. The fuse melts easily, thus breaking off the current. If we use thick wires as fuse, it may not melt, leading to a dangerous fire or an accident. Lightning conductor. A metallic rod, taller than the building, is installed in the walls of the building during its construction. Dispersion of white light by a glass prism. The prism has split the incident white light into a band of colors. The colors that appear at the two ends of the color band are violet, indigo, blue, green, yellow, orange, and red. The band of the colored components of a light beam is called its spectrum. The splitting of light into its component colors is called dispersion. Different colors of light bend through different angles with respect to the incident ray as they pass. The red light bends the least, while the violet the most. Thus, the rays of each color emerge along different paths, and thus become distinct. It is the band of distinct colors that we see in a spectrum. Subshells. Accordingly, electrons in each energy level are arranged in its sub-energy levels. Each sub-energy level in a shell is called a subshell. They are named as S, P, D, F respectively. Each main energy level except K has more than one subshell. The number of subshells in each energy level is equal to its shell number. Electron configuration. The electron configuration and energy levels of the first 20 elements in the periodic table can be taken. Electrons in an atom occupy in different shells. An atom can have different electron shells. The first shell can hold only 2 electrons. The second shell can hold a maximum of 8 electrons. The third shell can hold a maximum of 18 electrons. The hydrogen atom has 1 electron, and it occupies the first shell. Helium has 2 electrons, and they occupy the first shell. Saturated and unsaturated carbon compounds. Carbon has the unique ability to form bonds with other atoms of carbon, giving rise to large molecules. This property is called catenation. Compounds of carbon, which are linked by only single bonds between the carbon atoms, are called saturated compounds. Compounds of carbon having double or triple bonds between their carbon atoms are called unsaturated compounds. In ethane, 2 carbon atoms bonded to each other by sharing 1 pair of electrons. There are 3 unsatisfied electrons in each carbon atom. Each carbon atom shares 1 electron pair with 1 hydrogen atom. Structural isomerism in coordination compounds. Linkage isomerism. Linkage isomerism arises in a coordination compound containing ambidentate ligand. In the example given, the nitrite ligand is bound through oxygen, ONO. And the nitrite ligand is bound through nitrogen, NO2. A simple example is provided by complexes containing the thiocyanate ligand, NCS. Coordination isomerism. This type of isomerism arises from the interchanging in its coordination isomer, Cr, NH3, of 6, CO, Cn of 6. The NH3 ligands are bound to Cr3+ and the Cn ligands to CO3+ ligands. Stimuli. Changes in our surroundings that make us respond to them are called stimuli. Cockroach moves away from light is an example. In some plants like mimosa, commonly known as touch-me-not, leaves close or fold when someone touches them. This is an example for response of plants to stimuli. Human brain. The brain has 3 major parts or regions, namely the forebrain, midbrain and hindbrain. Cerebellum in the hindbrain is responsible for precision of voluntary actions and maintaining the posture and balance of the body. The forebrain is the main thinking part of the brain. It has regions which receive sensory impulses from various receptors. Many of the involuntary actions like blood pressure, salivation and vomiting are controlled by the midbrain and hindbrain. Spinal cord. Backbone or spine, it is also called the vertebral column. It is a chain of small bones, called vertebrae. It protects the spinal cord, which carries messages between the brain and body. It also supports the skull, ribs and limbs. Animal's nervous system. Nervous system is made up of an organized network of nerve cells, or neurons. Which is specialized for conducting information via electrical impulses from one part of the body to another. Nervous tissue is made up of an organized network of nerve cells, or neurons. And is specialized for conducting information via electrical impulses from one part of the body to another. Introduction to Arithmetic Progression. Look at the arrangement of logs. There are 16 logs in the bottom row, 15 logs in next row, 14 logs in the row next to it, and so on. In this ladder, the length of the rungs decreases uniformly by 2 cm from bottom to top. Nth term of an arithmetic progression. Nth term of an arithmetic progression, with first term a and common difference t, is shown. So, the nth term of an a, p with first terms a and common difference t, is given by a, n equals a plus n minus 1 into d. Trigonometric ratios. Consider a triangle XYZ, right-angled at y, and angles x and z are acute angles. Z is the side adjacent to angle Z. Sin Z equals opposite side divided by hypotenuse. Cos Z equals adjacent side divided by hypotenuse side. Tan Z equals opposite side divided by adjacent side. Cosec z equals hypotenuse divided by opposite side. Sec z equals hypotenuse divided by adjacent side. Cot z equals adjacent side divided by opposite side. Consider two triangles ABC and DEF. Angle A equals angle D, angle B. Corresponding sides of two triangles are proportional. Introduction. Polynomial is an algebraic expression consisting of multiple terms. Constant is the term. In this polynomial there is only one variable. The real number that precedes the variable is called coefficient. Types of polynomial. The real number that precedes the variable is called coefficient. A polynomial involving one variable is called a polynomial in one variable. Based on its degree, a polynomial can be called as linear polynomial, quadratic polynomial. A polynomial of degree 1 is called a linear polynomial. A polynomial of degree 2 is called a quadratic polynomial.